Okay, so twice now it's stopped recording. I already did one all the way through. And then the second one, I looked at it as I just finished number one and it stopped recording again. So that's why you probably see this lovely eraser, because I erased it all instead of rewriting everything, all my problems again. So I guess I have to keep looking at the screen to make sure that it continues to record. Hopefully it will, so we can get through this. All right, so what is the kinetic energy of a 600 kilogram object moving 18 meters per second? So I already circled that we need kinetic energy. We have a mass of 600 kilograms and a velocity of 18 meters per second. So I need all of those variables, a KE, an M, and a V, because that is all the variables in the equation. So in this case, I put the circle out there. If we're looking for kinetic energy, we'll be able to use our base equation, but we can also use the circle to figure out our base equation if we don't have it written down in front of us, and I'll show you that in just a second. So since we're looking for kinetic energy, it's going to be X joules. My mass is going to be 600 kilograms, and my velocity is moving at 18 meters per second. So I need to find out what equation I'm using. Since I'm looking for KE, if I cover it up, I have 1/2 mass next to velocity squared. That means I multiply them. So my equation will be kinetic energy equals 1/2 of the mass times the velocity squared. So with that said, I can just go ahead and plug everything into that, all the variables. So my KE is X joules equals 1/2. Now I'm going to put my mass in parentheses so I remember that I'm multiplying a half by it. And then I'm going to multiply all of that by the velocity, 18 meters per second. And I'm also putting parentheses around that and putting the squared on the outside to remind me that I square everything on the inside. I have to square the 18, I have to square the meters and the seconds in order for it to give me the correct units. So the first thing I need to do is the separate. I have to do these separate. I have to solve my half times 600 first, and then my squaring my velocity, and then I can multiply those two numbers together. So I already know that a half of 600 is 300. So I'm going to put 300 kilograms. If you didn't know that, or you get a number that's harder and you want to multiply in your calculator, remember a half you can divide by 2, the number by 2, or you can multiply the number by 0.5, which is the decimal of 1/2. So 300 kilograms, 18 squared. I know that in my calculator I can do 18 times 18, and that's going to give me 324. But remember, I'm also squaring my meters and my seconds, so it's meters squared per second squared. So now I can multiply my two numbers. So I already have 324 in the calculator, so I'm going to go times 300 equals 97,200. And I know it's a kilograms. I'm going to write it down here so I can look at it. Meters squared per second squared. Well, we already know that we don't use that, so we call that a joule. But later we're going to break down the joule multiple times to solve for units. Okay, the next one. What is the mass of a truck that has 150,000 joules and a velocity of 10 meters per second? So now we're looking for mass. It's going to be a little bit tougher this time. We have to rearrange the equation. So I still have a K, E, M, and V that I always have to find. So my kinetic energy is given to me this time at 150,000 joules. My mass is given, or not given to me, it's what I'm looking for, X kilograms. And my velocity is given, I don't know why I wrote 18 there. I was thinking of the one above, 10 meters per second. All right, all my information's there. Now I need to find the equation I'm going to use. So if I'm looking for mass, I have to cover up the 1/2 mass in my circle. I'm not going to get rid of the half in velocity yet. I'll get rid of it after. So that gives me KE on top and velocity squared on bottom. So I know that 1/2 mass equals KE on top, velocity squared on bottom. So that's kind of messy. A lot of people like to try to just plug in the number, square it, and then at the end they go half the mass, and it doesn't work out. It's the wrong answer. So instead, remember, we have to get rid of the half first. So anytime you have a fraction, you multiply it by its reciprocal to get rid of it. But since I did it on this side of the equation, I also have to do it on this side of the equation. So that's going to leave me mass equals, because the KE, the half is gone, KE times 2 divided by velocity squared. And that 1 times 1 doesn't matter, right? So we just ignore the 1 because it's anything over 1, you ignore it. So now I have an equation where I have no halves in there, no fractions that I have to deal with after. Now you could have waited till the end and multiplied by 2, but it's just easier to have this equation in the beginning. So I'm going to highlight this so we know that that is the actual equation we're going to use, since we've gone ahead and wrote a bunch of stuff up here already. So let's take all these numbers and plug it in. So x kilograms is my m, equals my kinetic energy, 150,000 joules times 2, don't forget that. Now divide that by my velocity squared, so 10 meters per second. And again, so I don't get confused and forget to square everything, I put the squared outside the parentheses. So 150,000 times 2, I know that in my head as 300,000 joules. Carry over the unit. Now on this side, we know that 10 times 10 is 100, so I already know that 10 squared is 100. But I also have to square my meters and my seconds, so it's a meter squared per second squared. So then I can solve by doing 300,000 divided by 100. I can can't figure it out in my head. I can always remember I can cancel zeros out and leaves me with 3,000. Now, I know that I'm looking for a kilogram, but how the world did we get that with these units? So remember, the joule breaks down. We already did that up here. The joule breaks down to a kilograms meters squared per second squared. I know I wrote that really small. But that means I cancel out my meters squared per second squared because I have that on both top and bottom, leaving me with just the kilograms, which is what I need to get 3,000 kilograms of mass as my answer. I squeezed that in really tight there, but hopefully everyone can see it. I keep having to look and watch and make sure it doesn't stop recording. So I'll zoom in a little bit better there. Oh no. Okay, no, it didn't disappear yet. It scared me for a second. Okay. What is the velocity of a cheetah that has a mass of 60 kilograms and a kinetic energy of 75,000 joules? So now I'm looking for velocity, but I'm still in a kinetic energy problem. Therefore, I still need a K, E, M, and V to solve. So my kinetic energy is given to me at 75,000 joules. My mass is given to me at 60 kilograms. And now I'm looking for velocity in this case. So I need to figure out my equation. Now I'm looking for velocity. That's going to give me, I'm going to cover up the V, and that's going to give me KE over 1/2 mass. And I'm keeping the V squared for now. So I'm gonna write it right here so I have some space. V squared equals kinetic energy on top, 1/2 mass on bottom. All right, here we are in that weird, you've got a fraction on the bottom of a fraction thing. Let's get rid of the fraction on the bottom, the half, by doing the same thing we did before, multiplying it by its reciprocal, which also means I have to do that on the top. So again, that helps me get rid of that half. So I'm going to move it over here, and now I have velocity squared equals KE times 2, because the over 1 doesn't matter. It's on a parenthesis, there we go. And I'm going to divide that by just my mass because I got rid of the half. But I'm not quite done. I don't want velocity squared. I want velocity by itself, just V by itself. So anytime you square something, you can do the opposite to get rid of it, which is square root it. If I do it to one side, I got to do it to the other side. So ultimately, that's going to leave me with my final equation of velocity equals KE times 2 over mass, and that whole side will be square rooted at the end. So this is my final equation I'm going to use. And I'll highlight that in the box just like I did the last one so we can remember that. All right, here we go. So let's solve by plugging in what we have over here into our equation. So velocity is x meters per second equals my KE on top, 75,000 1,000 joules times 2. Now I'm dividing that by the mass. I already got rid of the half, so I don't have to worry about that. That's great. So now I multiply 75 by 2, because that's everything on the top that has to be solved, which I know 75,000, times 2 is 150,000 joules. Dividing that by my mass, since there was nothing to do on the bottom, I just bring over my mass. So I'm going to start with doing the numbers. 150,000, dividing that by 60 equals 2,500. Now let's figure out what units are, because this is where everyone gets mixed up. They're like, oh, we're done. No, you're not, guys. Remember, I almost forgot to write this. We've got this square root at the end. So I got to keep doing that at the end. I'm not done. But I also need to know, let's look at the units. A joule divided by a kilogram. So remember, a joule is a kilograms meters squared per second squared. I have a kilograms on top and a kilograms on bottom. I'm left with a meter squared per second squared. That's not what I want, right? Because meter squared per second squared isn't an actual unit for anything that we're trying to find. So that reminds me, oh yeah, I have to square root it. I have to square root the 2,500 and also the meter squared per second squared. So for meter square root, I have to flip my calculator sideways. Maybe doesn't like me. Okay. Okay, I'm going to try that one more time. Calculator. There it is. Turn. There it goes. All right, 2,500, and my square root button is the little squared over around the X with the 2. So that leaves me 50. So I'm going to say equals, and remember, it didn't just square root the number, it also square rooted the units. So now the squared on the meter is gone and the squared on the second is gone, leaving me exactly what I need, which is a meters per second. So 50 meters per second is the velocity that Cheetah is running. They are fast. Okay, now we're going to move into the potential energy. So the kinetic energy is done. Let's move into the potential energy. Excuse me. And I'm going to go ahead and put down the circle, because I didn't do that for potential energy yet, because there is the nice circle, mass, gravity, and height all go on the bottom. So all three can fit on the bottom because they're being multiplied by each other. All right, what is the height of a 2.5 kilogram book with a potential energy of 735 joules? So my equation says I need P, E, M, G, and H. So I have to have all those variables. Can't forget. All right, so we're looking for height. I'm just going to go down and say X meters for that, because it says I'm looking for it. I have 2.5 kilograms of mass. I have a potential energy of 735 joules. And I don't have gravity given to me, but I have to remember it every time that it's 9.8 meters per second squared. Remember, it's an acceleration unit. So this is why I always am picky about making sure when you do a squared of something like this up here, you put it in parentheses with the squared on the outside, not to be confused with accidentally using the meters per second squared unit, which is an acceleration unit. Okay, so to get the equation, I'm looking for height, cover up H, and I get PE on top, mass and gravity on bottom. So looking for height equals potential energy on top, multiplying mass and gravity on the bottom. So now I'm just going to plug it in. So if I'm looking for height, again, X meters equals my potential energy on top, 735 joules, and my mass and gravity on bottom, so 2.5 kilograms multiplied by 9.8 meters per second squared. And notice I kept the squared inside the parentheses because it's part of the unit, which will remind me not to square anything on accident. So now I need to solve everything on top and bottom. There's nothing to solve on top. So 735 joules. And I'm going to solve everything on bottom. So 2.5 times 9.8. Let's get the calculator up again. So 2.5 times 9.8 equals 24.5. Now, what do I have? A kilograms times a meters per second squared. So let's figure out how we're going to get to where we need, which is just a meter. So if I do the division first, let's get the number. 735 divided by 24.5 equals 30. So I know it's going to be 30. But how do I get to 30 meters? Well, a joule is a kilograms meters squared per second squared. Get rid of my kilograms. One of the meters on the bottom gets to go, the meter on the bottom gets to go away, and only one of them on top, because that's a meter times a meter. So get rid of the squared, leaves me a meter by itself. Get rid of the second squared on top and bottom, and that meter by itself is what I need, and that's how I got 30 meters of height. Okay, last one. What is the gravity on a planet? So we're going to go outside the box here. We're going to leave Earth, go to another planet. But it's got a 95 kilogram person standing on a 65 meter high cliff with a potential energy of 22,800 joules. So in this case, I've given you 3 numbers so you can find gravity, because we're not going to use the standard Earth gravity, as we're not on Earth for this problem. So I still need all the variables to solve, and my potential energy is given to me at 22,800 joules. My mass is given to me, it's a 95 kilogram person. My gravity is what we're looking for this time, x meters per second squared. Remember, gravity is an acceleration unit. And my height is given to me at 65 meters. So I still can use a circle even when I don't have gravity. So I just cover up G. I use my pencil eraser since it's smaller than my finger. I get PE on top, mass times height on bottom, since they're still next to each other and they're still being multiplied, even though the gravity was taken out. So I'm looking for gravity. G equals potential energy on top, mass times height on the bottom. And we can solve for the gravity. All right, let's plug it in. Gravity is going to be x meters per second squared equals my potential energy on top, 22,800 joules. My mass and height on bottom. So my mass is 95 kilograms. And I'm going to multiply that by my height, 65 meters. And now I'm ready to start solving. Everything on top, everything on bottom. Nothing to do on top, so 22,800 joules gets to go over. Multiply 95 times 65 on the bottom to get what I need for the bottom half. So 95 times 65 equals 6,000. Oh, why did I say 65, guys? I swear in the problem it's 60. So it is. It's 60 in the problem. My bad. I don't know why I had 65 in this problem here. Must have been writing too fast. There we go. It's because I did it twice already and I just was so rattled. Turn those to 60. Okay, let's try that again. 95 times 60 equals 5,700. And that is a kilograms times a meter. So there's not really anything to do there except for say kilograms dot meter. So kilograms times a meter. So I can do the math, but first let's look at this so I don't run out of room. Let's look at how we're going to get to a meters per second squared from this. A joule is a kilograms meters squared per second squared. Okay, and I have a kilograms times a meter on the bottom. Kilograms disappear. Get rid of them. Meter on the bottom cancels out the squared of the meter on the top, and there's no seconds on bottom, so I have to keep both the second squared. So look what's on top, a meters per second squared. That's what we need. And if I do the math, 22,800 divided by 5,700, I get 4 meters per second squared. That's what I need because it's a gravity unit, an acceleration unit. And that tells me that planet has a gravity of 4 meters per second squared, which is less than our gravity here on Earth. And it didn't stop, so yay. But we are done.